Alright, so let's begin. So today I wanted to talk generally about, and I know that you've kind of already done a lab about this. That's sort of my fault. I should have actually delayed the labs by a week during your exam. So I wanted to talk about importing modules, okay? And so I want to do this from the perspective of Project 2, because you have to actually do a little bit of importing in Project 2, and then I'm going to do some more general stuff. So the initial stuff we're going to do, it's going to be relevant to Project 2 and maybe 3. It's going to be useful and good stuff. The stuff that I do later on in the class is going to be totally useless, you know, but probably far more interesting. Okay. Okay, sorry, hang on, let me send the right link. Okay. Alright, so, sorry about that. Let me get back to actually lecturing. Yeah, I guess it is. Okay, so, what am I doing here? Click. Alright, there we are. I'm back, we're back. So the only thing I'm going to say is that unfortunately I didn't click on the ultra low latency, so it's going to be, if you have a question, you'll just have to kind of wait for me to see it, or you'll have to ask it, and there's going to be a bit more of a delay. So, okay. All right. So, all right. So let me talk about importing modules. So there's a bunch of different modules in Python that you can import. And so what does importing mean? And the answer is basically importing is it's a way to include code or use code that you basically didn't write, at least most of the time, or at least that's in a different module. And you can understand module to mean either directory or file or place, etc. So you can understand it to mean a bunch of different things, but in this case, generally what we're going to mean is that it's in some different file, and you want to include that code because you want to use that code. So you might notice that in the past I've used, I've imported, for instance, the time module, for instance. There's a whole bunch of pre-provided modules in Python. I'm certainly not going to go through even 1% of them. I mean, well, maybe 1% of them, but that's only because 1% would be 1 out of 100, and I'll probably go over 2 or 3 modules. So, but the point is that there's a huge number of modules, and then you see that there's 2 different ways to import. You can either import like this, and so what this is going to do, this will import the module under the kind of scope or module name of time. And so what do I mean by that? So it's going to import the module so that if you ever want to use anything from the module, you have to go time dot, right? So if you do something like this, you need to do time dot, and this is saying module dot something, right? And so here it's going to be module dot, for instance, maybe process time or clock get time, time ns. So maybe this is the time in nanoseconds. So let's print out the time in nanoseconds. Let's see what that does. All right. Sure. Okay, so if a nanosecond is 10 to the minus 9th seconds, then what is this number? Right. So this is the calculation that I would do. So this is the number of, I guess, nano or seconds that my computer has been on. Let's see if this is a reasonable number. Divide by 3600 to get the number of hours. Divide by 24 to get the number of days. Divide by 365 to get the number of years. That is not a reasonable number. I have no idea what that number really means. Okay. Cool. So what if we did something else? Time.time, right? And we printed that out, and then we said for I in range, say 1 million, and then we, we do something like I plus equals 1, some garbage calculation, and then we print out time.time again. Let's see what happens there. Let's get rid of this time.ns. All right, so what happened here? So the time was 161.964.0550 dot blah 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 blah, and then here, let's see, after a million calculations, after a million little additions that were kind of garbage additions, the time was 161.964.0551.00. So as it turns out, the difference in time was about 1/10 of a second. Cool. Right? And so you might think, okay, well, that's a useful module, but I'm not really going over the time module because you're ever going to actually use it in this class. The reason that I'm going over the time module is because I want to tell you how to import things, okay? And that's really what I want you to know. So let's do another module. Let's import. How does it know a class from an import? Good question, actually. The answer is that if you did something like call something like time class, and then you decided to say time equals time class like this, the answer is that because you would declare the time, this time second, it would actually screw up the definition of this. So once you import a module under the name time lowercase, you cannot declare a class with the same name. Because if it does, then let's see, attribute error, time class has no attribute time. So the problem is that Python just goes with whatever happened latest. And so in this case, this happened later. And so it overwrites the time, and I know I'm being stupid by spelling it out, but what I mean is lowercase time, that name was just overwritten, right? That name does not exist anymore. So, and now it's this new time class, which I've just, the point is that the time class is garbage. It doesn't have anything in it. It doesn't do anything. It's useless. But that's the point. Python cannot distinguish. Python treats modules and classes kind of in the same way, is the other secret answer to your question. Okay, so I'm going to delete this crap so that it works again. All right. Now let's import a new module, but let's do it this way. And you know that you've had to, I think you might have had to import random before, so let's import random. But instead of doing it this way, let's say from random. So here's another way to import things. Import, say, random, randint, seed. Okay? So what the heck is this doing, right? What this is doing is it's saying, read in the random.py file, which is somewhere in the deep, dark depths of Python, right? And you don't know exactly where that file is. Actually, you can open it up. You can say, here you can say, in PyCharm, let's see, where is it? You can say, go to, I think, implementation, or you can even go to declaration and stuff like that. And here is the random.py file, right? Here it is. So it's the file that you are looking at when you are, importing random. Now you might ask, well, there's all these other functions, there's even other classes, there's all kinds of stuff going on in here. but I don't need a huge amount of that, right? Like most of this stuff, for instance, I don't need almost any of it. So is it possible, and so there's even a random class inside of here that we almost never use, but there's also just the random methods and stuff like that. And so the point is that you look in this thing and you say to yourself, man, like, what if I only need these three functions? I only need random, I only need randint, and maybe seed, right? So what I'm going to do is I'm going to say seed on, say, time.timeNS, something like this. And I think seed actually takes a string or something, so maybe string of that. I could be wrong. Does seed take integers as well? I forget. Let's test it out. Seed is weird. Okay, so seed didn't explode, so that worked. So what does seed do? And the answer is, basically, how does a random number generator work, right? And the answer to that is, well, random. So I should, it's a dangerous thing to say. Really, there's in computers, there's no such thing as random. There's only really pseudo-random. And what I mean by that is that you have an algorithm that generates some numbers, right? And it generates numbers that to you look random, and if they're truly good enough or truly random enough, what they're going to be is they're going to be kind of evenly distributed, right? You're not going to see any, as you let the number of random numbers you generate go to infinity, for instance, you're not going to see any big lumps. And let me kind of demonstrate that to you right now. So let's say for I in range, say 100,000, and let's say, and I know I'm using some forbidden thing here, but whatever. So, okay, so let's do something like this. Okay, and so then what we're going to do is we're going to print counts at the end. And let's just see what happens. So let's explain what we're doing here. What we're doing is we're creating a list. Is it possible to have a true random? The answer is, if you believe in enough of quantum mechanics, you can. If you had a qubit, right? A qubit, which is a quantum bit that has some state a times 0 plus b times 1, and then you collapse the qubit state down to either the quantum state 0 or the state 1, and that would be a truly random thing, because what you would end up seeing is that that would be truly random. But the problem with that is that well, I don't have any qubits, basically, is the problem. And it also, the trueness of the randomness depends on your belief and your acceptance of things like the Bell inequalities in quantum mechanics and Heisenberg's uncertainty principle and all the fundamental underlying quantum mechanical rules that say that the thing is random. Like, it's always possible that technically we're wrong and there's some hidden variable theorem out there that will prove us all wrong, and it's actually just pseudo-random like everything else. But that's the point, is that there's nothing really truly random except qubits. Qubits are from the Bible. Qubits are quantum computers, right? Or quantum computer parts. Anyway, I mean, so your question is kind of similar to your previous question. The answer is, if you had a different function that was also called board with capital B, then no, Python wouldn't know the difference. So that's why you've got to be careful about what you name things. So you can't name things capital B, lowercase OARD again. Otherwise, it'll get overwritten. Yeah, I mean, you see it in the Bible. It's the Egyptian measurement of, like, you know, all I know is that from, like, the Ark and stuff, you know, it's like 800 cubits or whatever. I don't know. So anyway, let's try to show that this thing is kind of evenly distributed. So what I'm going to do is generate a random number between 0 and 100. I forget if it's inclusive of the top endpoint. I think it might not be. But if it is, then we're about to find out. We'll get an index error. Index error. Okay, 0 to 99 it is. There we go. So here's the distribution, and let's print this out in a more friendly fashion. For I in range 100, let's print out I and counts I. Right? Instead of printing out this long list that's really hard to look at. So here's what ended up coming out of this random function. And so basically when we generated 100,000 random things, we got 960 zeros, we got 1,008. Is it random if you run a time and print the last digit? It depends what you... I'm going to say technically no, but it's getting close to random, right? It's random from a perspective of the computer, but it's not random from a lot of other perspectives. Again, you know, so the point is here that you see that we're getting 960 zeros, we're getting 1,008 ones, we're getting 1,054 twos, we're getting 994 threes, etc. And you see that basically most of the digits, we generated 100,000 random digits between 0 and 99. And it's not exact, you know, it's not exact, I agree. But it is pretty close to a uniform distribution, which is what you're kind of looking for when you're thinking about a random number. You don't want it to be a purely uniform thing, because otherwise then it probably isn't random. You don't want it to be too perfect, you don't want to be too imperfect. This seems like a good middle ground, right? And like if we generated, let's say that instead of generating 100,000, we generated, say, 1,000,000 random numbers, we would expect the numbers to generate about, you know, it would be about 10,000 each, right? And you see that overall here, you know, as we go, basically it's like the limit as n goes to infinity of, you know, this random number process. It means that we expect to see about equal distribution. Well, these are kind of low, actually, I guess. But anyway, we expect to see approximately equal distribution of the values. That's really what we mean. And so, cool, that's a little bit of a random thing. All right. So let's actually reduce this back to, say, that, just to shorten the runtime. Here's another bit of random that you can do. So what you can also do with random is you can say, let's say that I need a number between 0 and 1. The function random is the thing that does that. So random is going to generate a number. 0 is less than or equal to random is less than 1. Or less than or equal to 1, I think. And so random generates some decimal number between 0 and 1. Generally, from what I can tell, fairly evenly distributed. And that's what that does. So if you ever need a floating random, use random. If you ever need an integer random, in Python at least, you use randint. And if you ever want to kind of, and so I guess I didn't discuss what a seed does. Yeah, unfortunately, there is a module in Python called random with a function called random. That is true, yes. And the only way we would be able to distinguish this thing is, for instance, if instead of doing it this way, if we would just said import random, like this, then what we would need to do in all these cases is random.seed and random.random. And for here, we would have to do random.random. Okay? So that's the distinction when we include when we just do a straight up import versus a from module import certain things. So, right, it makes us add random dot in front of everything. Okay? So, all right, cool. Let's get rid of all this crap so that it doesn't cause problems. All right, cool. So those are two modules that are inbuilt in Python, right? Every Python distribution has the time module. Every Python module has the CSV module. Not CSV, though that's also true. I was just thinking about CSV. It has time, it has random. There's a bunch of other modules that Python has. For instance, there's the JSON module, there's the CSV module, there's, what other kinds of modules does Python have? Requests, I think, is one of them. I don't know. There's a bunch of more. I mean, there's so many. It's hard to like think of any, all the modules together. There's some encryption modules. There's a lot of different modules. So let's actually pull it up and look up like Python modules. So, okay, this is not exactly what I'm looking for, but okay. Whatever, let's ignore this for now. All right. So, let's talk now about how you can make your own, or how you can import your own code. So let's make ourselves a little, this is not really a module, this is just another file, but let's think about how to make ourselves our own file. So what if we had to make it a different file? Let's see, what do we want this file to do? I guess that's the real question. What's a good thing for it to do? Maybe, okay, maybe we'll make something called primes, okay? And maybe you're sick and tired of writing an isPrime function, right? You're absolutely sick and tired of it. So you're just going to write an isPrime function inside of this module, or actually this file, and we'll write it, oh yeah, let's actually, I didn't actually say what seed does. What seed does is it changes the initial starting parameters for a random number generator. And the reason why we want to do that is, remember that all random number generators are pseudo-random. And so the point is that if you accidentally, if you don't specify a seed, it's possible that Python may allow the same seed to happen. So instead of having different random number generators, you'll actually end up having the same random numbers pop out over and over. So it's possible, and that's actually an attack on some people's programs, is where it's an attack where if you can get a program to accidentally generate the same seed, or allow Python to generate the same seed, then what ends up happening is, if something secure in your program depends on random number generation, your program becomes more vulnerable because the attacker can basically set their seed to your seed and run the same RNG algorithm. right? And so basically when you pull up a random number, they can pull up a random number. And you can kind of do this one for one, so you can kind of predict the random numbers that the other program is going to generate. And so that's why in general, setting the seed often to something like time.timeNS is like the first kind of easy way to prevent this. And the reason why is because it's very difficult for an attacker to know like what nanosecond you started the program. So it's a simple kind of feature, but it's also something that makes your program a little bit less vulnerable to attack. But again, that's totally irrelevant to modules. It's just important for random numbers. Okay. So let's implement an isPrime method, right? So isPrime is going to take a parameter n, which says an integer, and it's going to return true if prime, false if not prime, right? And so what we're going to do here is we are going to do something like this. We're going to say for I in range 2 up to the square root of n, maybe plus 1, and I guess I have to intify this because otherwise it'll yell at me. I'm not 100% sure if you need this plus 1, but I'm always a little bit afraid that if you got some kind of fractional result here and it rounded down, then it's possible that you might miss a factor. But I guess it should be impossible, but I'm always just trying to be careful. Also, I guess if it's a perfect square, then it won't go up to the perfect square. So you actually, no, you do need the plus 1. But that's totally irrelevant to our module business. So you basically say if n mod I equals 0, return false, and at the end you return true. And so you've seen this function written at least in the algorithmic context, and we know that it runs in from previous lectures we know that this runs in O of the square root of n time, right? Cool. But at this point we don't really care, right? Our only point here is we want to use it in this file, right? And it's in a different file. So what we're going to do is we're going to do something like this. We're going to import primes. And so you might notice that PyCharm is going to do something annoying. So this is not Python. This is not about Python itself. So this is actually going to run, okay? As horrible as it is, and I know that you're like, wait, but this is underlined. It's going to be an error, all this stuff. But just watch. I'm going to print 5, and then maybe isPrime, prime.isPrime, maybe? .isPrime 5, or primes.isPrime 5. And you notice this actually kind of worked. And you're going to be like, what the heck? It didn't import, right? It has a red underline here. It's not. This is no module named primes. It's very unhappy. But I'm going to run this thing, and you're going to see. You're going to see. Trust me. At the very end, it's going to print out a 5 with a true. 5 is prime. And then let's test it on something like 12. And is prime 12. Let's do it again. 12 is not prime for a lot of reasons, right? 12 is equal to 4 times 3, 12 is equal to 2 times 6, 12 is equal to... Well, I guess that's basically it. But you only need one example, so it's not prime. So, so that's how you import something in Python, right? You just import the file name without the .py, right? So that's how you do it. You import the file name without the .py. And that will import the file. But you're saying here, if you're working in PyCharm, you're going to say, I just can't really deal with this red underline, right? It's screaming at me that there's some kind of error with my code. So how do I fix this? Because I know for a fact that this code ran, right? Well, yeah, so I'll show you how to do that in just a second. So, this code ran, so there's actually no error. So what we need to do is get PyCharm to chill out, right? Because PyCharm is actually being a little bit over-aggressive here. So let me show you how to do it. What you can do is you right-click on the directory, and it's bizarre, right? You're going to be like, why the heck do I have to do this? But you have to do this, and you have to click Mark Directory as Sources Root. So you have to right-click on directory of your file, go to Mark Directory as Sources Root. And, I mean, eventually you're going to, like, if you become some really mega advanced programmer, you're going to come back and say to me, oh, well, that's obvious, you should have to mark the directory as a source root or something like that. But now you're going to say, like, why the heck did I have to do that? Why couldn't PyCharm have figured out that the directory I'm currently in is the root of the code for which I'm importing the file, this primes file, and not to freak out? The answer is PyCharm in this one case is not actually very smart. And so in this one case, most of the time, like 99% of the time, PyCharm is smart. This is the 1% where it doesn't, it pretends, right? I'm not going to say it doesn't know what you're doing. It actually kind of does know what you're doing because it allows everything to work. It even kind of allows, remember, it didn't underline all this in red, so it worked. But it kind of pretends not to work. And of course that's really irritating. So anyway, so this is just, I know this is totally, I've spent like 2 or 3 minutes on this, and I know that it's totally irrelevant for the purpose of actually teaching Python, but I know that I've kind of told you guys to use PyCharm, and so when you get that red underline, when you're very confused, like what's wrong with my code, you just click on the directory, right-click, mark directory as sources root, you're done. That's it. That's what you have to do. And then you notice that red underline goes away and it's happy, right? So it's just modifying the compiler or interpreter to understand that actually you want to view this modules, etc. directory as a directory which is places where you can import from. Otherwise, it just doesn't understand that. Okay, cool. So, all right. So there was a question asked, like, what if I make a class called people, right? And what kind of things can people do, right? People have names. So self.name equals name. So yeah, what kind of things can people do? People can talk, and if they talk, most of the stuff they say blah blah blah. They can walk. So I don't know. How do people walk? I guess who knows, right? I'm not even going to implement that function. And then maybe, what is my name? Say, my name is something like that, right? And so, okay. So now you don't want to just import a function, right? A straight up function. You want to pull in a class. So what you can actually do here is you can say from primes import people, right? And so it's going to be grayed out right now because we haven't actually made a person a people. I guess that's actually a problem. We should probably call this person because the singular of people is person. Anyway, so so here's where I'm importing a class, right? I'm just importing an entire class. I can't, so if your question was, can you import a single function, import a single function out of a class that's inside another module, the answer is no. But the only reason for that is that you can't really import a function, you can't really use a function separated from its class, like, or I should say a method, right? If you have a function that's inside of a class, if we're going to call that a method, then the thing about the method is that that method is associated with that class. And you can't really pull it apart, because the problem is that if you look at the way that this class is implemented, you can't really call this function separately, because it requires a person class to be fed in so that you can get a name out of it. So if you didn't feed in a person class or didn't do person dot what is my name, then this function just would fail to run. And now some of these functions, you don't, this function is nothing, so it doesn't matter. This function is just a single print statement, so it doesn't matter. But this is basically the general type of function where you're actually using data from that class. So you can't import a single function out of a class that's inside another module, and that the reason for that is you can't use a function from a class without a function, maybe method if you want to call it that, without having an underlying class behind it. But you can import the class. Can you import the class? Yes, I just did, right? And so that's basically what's going to end up happening. So that's why, for the instance, and that this is where it's important for the project, right? Or where you're going to say something from like board import board, right? What that's saying is from the board.py file, right? Import the board class and allow me to use it without saying board.board. I can just say board, right? So that's the point. All right. So what else do I want to say about this? Yeah, so let's make a person, person. What's a good person's name? Archibald. And maybe, what's another person? Right, Hrothgar, the Speardane, right? So anyway, those are two people. So Hrothgar is going to poor Magellan, man. Charlemagne, yeah. So Hrothgar dot what is my name, right? And so my name is Hrothgar the Speardane. So the point is here that what is the point anymore? I guess the point is that what we were able to do, right? So, what did we learn just now? We learned that we can pull in a class type from another file, right? And that's what we learned. So person is not in this file, right? Or I shouldn't say that. Person is not defined in this file. That's a better way to say it. So person is not defined in this file, but we can create person instances. I guess that's what we would call them, right? Person instances. Good question. Good question. You notice that I'm always so if you call this maybe my header comment, generally all of my imports are right under the header comment. So why is this that we do that? The answer is tradition. You import right under your header comment. Is it possible to import other places? Yes. Is it terribly smart to do that? I'm going to say no, and there's two reasons for that. One, So one is that when you go back to modify your code, and you look at the top and you see all the imports, you may think that that's the list of dependencies, but if I had a secret import, right, if there's some secret import later, I wouldn't know that my code is actually dependent on some extra stuff that's not specified in the top. So I'd have to like read through the entire piece of code just to know what the dependencies are. So that's one problem. And the other problem is actually that, so if I did, so watch this. If I do time dot time here, right, we're actually going to see that time is not defined. And you say, but wait, I imported time. And the answer is order matters, right? I mean, as a mathematician, I would say these things are not commutative, right? And the reason why they're not commutative is because Python like literally reads lines of code line by line. So it doesn't care that there's an import statement here. It doesn't take any precedence. So the thing is that it tries to do time.time, it fails and dies. If, of course, you do something like this, it's completely happy, right? Right? It works fine. I guess we never actually outputted the time, so it's never going to display, but it doesn't matter. So this is completely fine. This is an error, right? And the reason is because we haven't imported that time yet. And so even though in some other languages it's possible the dependencies work in a different order, but in Python here everything code is interpreted exactly linearly. Okay, it just goes one line after the other, right? And so, if this piece of code is invalid, or I shouldn't say that. If this has a problem like this, then it's going to have an issue. So, yeah, that's a good question. Is where do you put your stuff? You put it right under the header. Can you do it in other places? Yes. Is it terribly smart to do that? No. And I think these two reasons are pretty good reasons. And the answer is because what ends up happening is if you don't put it at the start, you would end up with, tons of code, right? And you don't realize that the imports got pushed down, and then you will end up with errors, right? So that's why we put the imports all at the top, is so that the imports happen so that for the rest of the file we can use all of the code. All right. Similar to GL, we did a lab in PyCharm. I'm not 100% sure I understand what you mean. The answer is actually, so a PyCharm doesn't have anything to do with importing, right? So all of this code will work identically in GL. Right? There's no difference between GL and PyCharm. The only one slight difference was that PyCharm didn't recognize the fact that the primes file was in the same directory and should be imported and did some red underlining. That's the only difference between PyCharm and GL. Okay? All right. So I think today what I'm going to do, because I feel like it, let's do a little bit of GUI stuff. All right, so I'm starting a new file here. The reason why I'm starting a new file is everything in the previous file is basically allowed. Like, you are permitted yeah, I'm about to do something similar. I mean, not exactly that. I have two examples that I usually do for like the use of modules that you have to do other things than just import. So I usually do some GUI examples, and then I talk about Flask, which is web development. And I don't really have enough time to do a Flask lecture today. I'll do the Flask lecture next time. It's going to take a full thing. I might do maybe a day or two on GUI, a day or two on Flask, and then that'll be the end of the semester. So at this point, we're done. So this is the end of the semester. And so basically what I mean by this is that everything I'm about to say now is not for Project 3, or the final. It's for your future life, for your enjoyment, for anything but this class, right? We're going to do it in Python so you understand it, so that it's fun, but it's not directly relevant to our lives. Okay. You don't need to know how to do this. Well, I mean, technically no, right? I always hate to say, yes, you don't need to know it, but you don't need to know it. Okay, so there are non-provided GUI packages that exist, but let's say that you want to make basically, I think the right way to say it is, it's not so much that you don't need to know it, it's that this knowledge is currently, considered forbidden for use on Project 3, Project 2, Project 3, or the final, right? The other point is that you can't use it anyway, because it's a GUI thing, and GUI doesn't run on GL. But anyway, so I'm going to import something called tk-enter. And so I'm going to import it, and here's the thing. What is tk-enter? The dumbest answer to that is it's the graphical user interface package that's provided with Python. And you might ask, well, why is this bizarre tk-enter package provided with Python? Why don't they provide a better package? Is Project 3 another game? Maybe. I'm going to probably write it up tonight, so. Okay. So yeah, so I think the thing is to remember that GUI stands for Graphical User Interface. And, it's a bit silly now to think, because, so the term GUI is usually put up against something like CLI, which is a command line interface. So what you used to, so basically GL, Linux command line, the Windows PowerShell now. Technically Windows still has CMD, but it's kind of not. It's kind of defunct at this point. Right, and then I guess you could even say like WSL, if you know what that is, like Windows System for Linux, or Windows Subsystem for Linux, or etc. So these are all command lines, right? And so this is, so when the term GUI was invented, the funny part is that CLIs were what everybody used, right? What's a GUI? And nowadays, obviously, it's exactly the opposite. People, I guess this is the past, and this is the present is usually, people usually probably think like GUIs are the only interfaces with computers. What is a CLI, right? What is a command line interface? And, as the true programmers you are now, behind every GUI, there is a CLI, right? And the star is probably. I don't know if there's any purely GUI operating systems with literally no command line interface behind them. I'm going to say probably, right? Most likely that's the case. And the CLIs allow you kind of access under the hood in general, right? to operate on your computer in ways that sometimes you can't even do by the graphical interface. Okay. So, I mean, that's just a bunch of terminology. Who cares about terminology? But the answer is, like, if you're ever asked later on in your life, what's a GUI or GUI, graphical user interface, if you ever see CLI, it just means command line interface. And those are generally the two types of understood interfaces, right? I don't think there's a whole lot of... I don't think there's a type 3 of interfaces. It's either it's some kind of graphical thing or it's you're typing stuff in. I think those are really the two options. I could be wrong, but it's all I've ever seen. All right, so TK-enter is the GUI package. So what we can do is we can make a TK class. So there's a lot of TKing going on in TK-enter. TK is almost like a meaningless garbage set of characters. Really, that's the way to think about it. So don't be like, oh, what is a TK? A TK is a TK, right? Basically, just think of TK as meaning Windows, right? Or some kind of window. So, right, so here we're going to make a TK class. So my window is going to be equal to tkenter.tk. And then I'm gonna run two commands. I'm gonna set the geometry of the TK-enter. And now you might be thinking, oh crap, how complicated is this geometry gonna be? The answer is here it is, 800 by 400. So you might think, why is it taking a string rather than two arguments? Who knows? The answer is it's dumb, but whatever. So it takes a string, which is of the form number, and then literally the letter X, and then another number, right? And so this is the width of the window, and this is the height of the window. Okay, so the window should be end up being what should I say? Twice as wide as it is tall. Okay, and now what we're going to do is we are going to display. So my window dot we don't actually have to do anything to display it. It's visible by default, but I'm going to run something called main loop. And so you might ask yourself, like, what the heck is main loop? And so the answer is, this is the primary difference between a graphical user interface program and a command line interface program, is that a graphical user interface program, it basically needs to have, like, what this really is it's a while my window isn't destroyed, right? Get messages for my window, right? And then process message for my windows. And that's it. So basically what we're doing is we're making this particular window the kind of main window of the program. And as long as this window goes on, right, we're never going to get, we are at the end, right? So this function here, this main loop function, is basically hiding a while loop. The while loop is going to be, while my window isn't destroyed, it's going to get a message. And that message, so, again, what do I mean by a message? A message is like a click event, a type event, typing, resizing. What other kinds of things can happen? Who knows? Or literally just no event, right? It can be that nothing has happened, right? That's also possible. So all of those things are possible. It's just that what happens is our program is basically waiting in like a quasi-infinite while loop. Yeah, and that's the point, right? So, okay. Cool. So let's run the program, and that's enough. I mean, I've gone through the whole explanation about this. It's only 3 functions. I'm bored now. Let's run the program. Here we go. That's it, right? So is that interesting? Is that boring? I don't know. It is what it is. And now let's destroy the window. Let's click, destroyed, and then you see as soon as we are destroyed, we left this function, right? And then we are at the end, and the program ended. So that's how we do this. Yeah, whoa, a rectangle. Yeah, my window dot. Let's adjust the title. Let's call this Python GUI tutorial, right? So this will change the title. So there we go. So now we have, I don't know if you can actually read it, but the Python GUI tutorial is written right here, so that's good. Okay, cool. So, all right. And now you're instantly bored, right? You're like, this is boring. How do we do anything interesting with this? Like, for instance, let's add a button, right? Buttons are good. So let's make a function, add components, and let's run it, add components to my window. And so let's make a function called add components, call it main window. And so what we're going to do here is we'll say main window dot, or let's make a button, so tkenter dot button. And so I think, oh right, and so let me describe what we have to do here. So tkenter uses the term master for what's generally known as parent. So it's a weird thing, who knows why they chose that terminology, which is actually different from the vast majority of terminology that's used by other GUI packages, and also by operating systems. So basically the way to think about it is that like every window, every button, every edit box, like text box, menu bar is a window, okay? So that's the way to think of it. Every window, button, edit box, menu bar is a window. Or you can call it an object. I don't really care what you call it. And our main window doesn't have a parent. And so the reason why we know it doesn't have a parent is because it's kind of free floating, right? If it had a parent, then it would be contained within some other window. And you notice that here, it's actually not contained within anything. It's just free floating like this. So it doesn't have a parent. So the question is, so what do we do? So the first thing we need to do is make a button with the parent. And actually, let me look at my tutorial stuff because I always forget exactly. All right, and so then there's a whole bunch of crap that you just have to know. And what I mean by just have to know is you just have to look it up over and over. So the windows, so for a button, the label on the button is called text in this case. And then so that's good, right? This button, my button, has a parent, right? The parent is the main window, and then we have to place the thing within its parent. So let's just use the simplest way to do it. Let's just grid it at 0 and 0, and I'll tell you what that means later. And let's see what happens. Takes 1 to 2 positional arguments, but 3 were given. Oh, right, because it actually needs you to do row equal this, column equals this. All right, so here's what you get. You get a button that you can press. Now the button's stuck in this corner. We can probably fix that in a little bit, but the main point is we want this button to do something, right? Currently the button doesn't do anything. So how do we make the button do something? This is how we do it. We add another, this is called a keyword argument. So these things that you have inside of these functions here, text, row, column, are all called keyword arguments. All right. So we got a button. Now let's make the button do something. And so what the button is going to do is it's going to call my function press button. And you might say, but wait, there's no function called press button. Cool, now there is. Right? And I forget exactly, let's see. I always forget all of the stuff. Okay, I guess this one doesn't need any parameters. So, cool. So let's do this. So what are we going to do? I am going to make a message box pop up. Okay, so how am I going to do that? In order to do that, what I'm going to do is I'm going to say tkenter.messageBox. Well, first actually we have to import it. So let me just import from tkenter.messagebox import, what is it, message box, or I forget, what is it exactly? Show info. All right. There's also another set of functions. There's I think there's a show error, show warning, but you can find all this stuff out. So the moral of the story is with all this stuff, if you're like, well, how does he know all of this? The answer is I'm cheating off of my own previous code. And the reason why I do that is because, as it turns out, this kind of stuff differs for every different graphical user interface package, and it's kind of hard to remember if you haven't done it in a few months. And so the other way to do it is what you do is you look up tkenter documentation. Okay? That's what you do. You look up tkenter.messagebox. And here's the documentation for it. Right? tkenter.messagebox module provides a template base as well as a variety of convenience methods for commonly used configurations. The message boxes are modal and will return a subset of true, false, okay, yes, no, based on the user selection. Common message box styles, blah, blah, blah. Oh, hey, look. When you get out of this class and you're actually doing coding using modules, you must read the documentation. Right? So for you, at least in 201, I guess the way to analogize it is, right, up until this point, your documentation has been the homework descriptions and basically whatever you can read off of the Python website. But in real life, the documentation is going to be anything you can find on the internet that explains how these functions work, right? And so here you see how the showInfo function works, right? You see it takes a title equals none, so by default it's not going to have a title. Message equals none, so by default it's not going to have a message. And then it has all these options. Now I don't even know what these options are. They're not. Look at this. It's not even documented. This is yet another good example of how documentation isn't always perfect, right? If this documentation were good, it would say, in the keyword arguments here provided, you must say that something is something, something, something. But it doesn't even say that. So, right, so, okay. So let's print something out when we press the button. You have pressed the button. The button. Right? You have pressed the button. And now let's run the program. And then, so here we're not going to make a message box pop up yet. But you notice this, as soon as I press the button, you have pressed the button. Right? Cool. Right? That's some good response right there. Right? So we press a button and it prints a message. We're happy. But maybe we wanted to do something graphical because this is a graphical user interface program, and most of the time people don't want to be reading some kind of console output for whatever they're doing. So so basically here what we're going to do is we'll actually do something like, oh, okay, maybe show info, and then let's see what we can do. Let's show info. The title is going to be first GUI tutorial, and the message is going to be you have most likely pressed the button, right? And that's it. You just put in a title, and you put in the message, and then here we go, right? You click press me, you have most likely pressed the button. The good news about this is that it won't let you press the button again because it's one of those like locked out things. It's taking precedence over the other window, so you can't create a billion of the message boxes. Right, but yeah, you press the button, that's it. Cool. All right, so you're sick of buttons now. You think to yourself, right, now I'm sick of buttons. I want a text box, right? And the reason why you want a text box is because you think to yourself something like, well, you know, if all my program is literally just a bunch of buttons, then things are not necessarily very good. I want a text box, okay? So give me a text box. Okay, let's get you your text box, right? It's going to be a tkenter.entry. So now again, you might say, how did I know it was going to be called an entry rather than .textbox or .whatever, right? And the answer is read the documentation, right? That's the only answer to any of these questions is unfortunately read the documentation or go and get a tutorial, right? So in this case, it's called an entry. And remember that the entry also takes a master, which is really just the parent window. So we plug in main window. And then let me look up the documentation for TK entry. I don't know if this is great documentation. I remember this website being kind of garbage, but notice how it's W equals entry master option. That's perfect, right? But at least they kind of describe it here. Now here's all the things that you can put in the options. So BG is the background color. BD is the size of the border around the so you can change a bunch of this stuff, right? Font, if you want to mess with fonts, that's actually kind of difficult. FG is the color of the text. So FG normally means foreground. So whenever there's like a BG for background and FG for foreground, FG is normally the color of the text, and BG is normally the color of the background. This is justification, etc. So there's a bunch of different things, right? And then this is one of the important ones, a text variable, and then here's width, which I'm going to use. So just watch me use them. So here what I'm going to do is I'm going to say the text variable, and you're of course going to ask what the heck is that, but don't worry about it. Text variable is going to be, actually I'll create the text variable first, tkenter.stringvar, and then main window, and then what we'll do is my string var equals this, and we'll feed that in, width equals 20. And so then what we'll do is we will grid row equals 1, column equals 1. Okay. Actually, row equals 1, column equals 0. And so this should display directly under it. Okay. And actually, let's return my string var. Okay. And so what we'll do here is we will say the string equals this, and so it's a global variable. And then here what we'll do is instead of displaying when you press the button, here we'll actually display the string.get. And so let me explain what the string vars are. So normal strings are just variables, but these string vars are special strings which are they detect changes. And so basically what happens is that whenever this string is changed, it can kind of update itself And it's actually just it's a class that does a lot of kind of update operations on strings. And so, and it works with the tk-enter graphical package, right? So whenever, basically setting the text variable equal to myStringVar, what that does is whenever you modify the entry, whenever you type something into the entry, it's going to change the myStringVar so that it matches whatever the entry says. So that's what this text variable is doing, right? Text variable, if I can type it, links the text, the string var to the entry, right? So that's what this parameter does. The width equals 20 just makes sure that we have 20 characters of width, so we can type things, right? Because I think sometimes if you don't set it, it'll set it to something really small by default, and the thing will just be mega small. So let's run this and see what happens. All right, so it's hard to see here. Maybe maybe I'll change the background color. BG equals black. I think FG equals white. Let's try it again, so you can actually see it. It's very difficult to see here, I admit. Here we go. So now I've changed it so that the background color of the edit box is black, and the foreground, hopefully the text color, is white. So now I'm going to type something like CMSC 201 is great, right? And then let's see what happens when I press this thing. Press me. And so here it says CMSC 201 is great. And so the question is, how did it know that string, right? How did it get that string out of the entry box? The answer is, this string variable keeps getting updated whenever you type something into the entry. And then when we click the button, remember I had replaced this with the string.get, right? And so this is the global variable here. So you might be saying, don't use global variables, but remember most of this is forbidden anyway, so I can use the global variable if I want. And so the point here is that this global variable allows us to get the actual underlying, not just the string var, right? So it's a little bit hard to say, but it's not getting us the string var, it's actually getting us the underlying str, right? The underlying string. And the reason why we want that is because then we're going to feed it into the showInfo function. So the string var is a complicated kind of change mechanism. It's a tracking mechanism for strings, right? It's allowing some kind of entry box or some other component to modify a string and update it all over the time, and you remember that Python strings are immutable. So basically this string class, string vars, is kind of like a mutable version of a string, right? Anyway, so we have the string.get, and that's what we do. And so that allows us to get the underlying string, and so now whenever we type something in, it will display. So now we can say something like, project 2 is hard. And then you click it. Now it says project 2 is hard. You see that whenever it updates, right? Whenever you update the thing, you say, turtles all the way down. And so you click press me, and so now it's turtles all the way down. So, okay, so that's a good introduction to modules, I think, and it's a good introduction to the basics of graphical user interface programming. So the thing that the things that I've kind of taught you with this GUI programming are the use of imports, the fact that you need this main loop to kind of, basically, let me show you what happens if you don't put the main loop in. I think that's the last thing I'll show you. We're at the end, we're done, right? Because the thing is that it'll create all the windows, and then it doesn't wait for messages. It just exits the program, right? That's the problem. It can create all the windows, but the windows have a very short lifespan, because as soon as your program dies, all of the windows, the operating system will kill off all your windows. So that's why you need this main loop. The main loop is basically an infinite while loop, as I say, to keep your program running. And then, here's the things, we're basically using an edit box, which is an entry in tkenter. We're using a button, which is thankfully a button. And then we're kind of gridding them on. So gridding is just kind of the easiest way to kind of put them on a board. Just pretend that the window is kind of checkerboarded and you can put it in rows and columns. That's how to do it. The good news is here, is that tkenter might run slightly differently on different operating systems, but it will actually run on Linux, it'll run on Windows, it'll run on Mac. It does not actually, the code itself doesn't care what operating system you're running it on. Sometimes there's little bugs where the operating systems in tkenter don't function perfectly identically across OSs, but it is true that this code will, I guess that's one definite advantage of tkenter, is that it is cross-platform. Okay, so it is cross-platform. It has a lot of disadvantages. There's a lot of things that it doesn't do very well. If you try to do any real, like, massive project with it, it becomes actually kind of hard to use. But if you're just learning Gui packages, it's a good one to start out on. And the moral of the story in terms of learning Gui packages is that once you learn one Gui package, you can kind of pick up any other Gui package. So it doesn't really matter if you pick the first Gui package that you learn is something that's not great, as long as it's easy to learn. Yeah, so the things that you've learned here are, you can add components to Windows. Windows have parents, right? So even children Windows can be the parents of other Windows. So, and I can show you that kind of stuff next time, where you'll have children of children of children, or parents of parents of parents, or something like that. Anyway, so what else do I want to say about this? Yeah, I think that's basically it. And then, of course, the string var nonsense. If you don't completely understand how the string var is working, or why it's necessary, or what it's doing, that's okay. I haven't done a perfect job of explaining that, but I think the point is that if you want to, I'm about to post this code to the GitHub, so if you're interested, you can just run this code yourself and just play with it, right? So that's the moral, that's the main argument here, is that whenever you feel confused or you're interested in something but you don't know exactly how it works, just play with it and see, what happens if you change it to a string, or if you change it to something else, or whatever happens, if you do something like that, just see what happens. And if you break stuff, that's good because you've learned, and if you didn't break stuff, then you made something new. So that's the moral. Do that. All right. I think that's it. So I'm just gonna, lesson on modules. The only reason why I'm stalling is because I'm posting things to GitHub, and I will end the lecture as soon as I am finished doing that. All right, posting it to GitHub. It's up. So I think we're good. I think we can end the lecture now. Yeah, so let's play the outro.